This is a lab problem from section 4.1. They want us to find the critical numbers of the function, and our function is going to be t raised to the 3/4 power minus 8t to the 1/4 power. So if we were looking for the critical numbers for this function, what we want to do is we want to take the derivative and find when the derivative is either equal to 0 or undefined. And because we have fractional powers here that's less than 1, the chances are we might be able to pop up or come up with denominators when we take the derivative. So I have this off to the side over here where we're going to take the derivative. And the derivative of each of these terms is going to be, it's just a power rule. So we're going to start off with the 3/4 times t raised to the 1 minus, or 3/4 minus 1. So 3/4 minus 1 is going to be 3/4 minus 4/4. I think that's going to be a negative 1/4. So this negative power brings us down to the denominator. So we'll keep that in mind. Next term is going to be 8t to the 1/4. So we're going to bring the negative down, or we're going to bring the 4 down. 4 times, or 8 times 1/4 is going to be 2. And then we have a 1/4 minus 1. So that's 1 minus 4. That's going to be a negative 3. So that's 1/4 minus 4/4 is what you can think of. So here is our derivative. Now we can plug it in just like this, and I'm sure that they would take that as an answer because it's an equivalently correct answer. But we are interested in solving for when this derivative is equal to 0 or undefined, which means we probably want to write it as a fraction. And so what we're going to do is we're going to rewrite this as a couple of fractions and see if we can find common denominators. We have t to the negative 1/4, so that's like 1 over t to the 4th. So let me change this a little bit. 1 over t to the 4th, but this time we will have a positive power if it's sitting in the denominator. And the same is going to go for this guy, t to the negative 3/2. That's actually going to be equal to 1 over t to the negative, or positive 3/2 this time. So let me write it as 3/2, or 3/4, sorry. So now we have something where we have a couple of denominators, and now let's see how we can find common denominators. I think 3/4 is a larger power than 1/4, and what I want to do is I want to ask, what do I multiply this by, this fraction by, top and bottom, so that I get so that I get the common denominator. I have to multiply this by the same number on top as the same number in the bottom, or same expression. So I think if I multiply this by t raised to the 1/2, that's actually 2/4. And if I multiply this on top and in the bottom, then we will have a common denominator of 3/4. Okay, so that's our plan. Let's go ahead and do that. Our denominator here will become 3/4. We will have this as t to the 1/2, and then that would be gone. So multiplying these two fractions here will give us this one fraction, and now we have a common denominator. Well, except for this 4. Let's see. Let's make this into an 8/4. And then now we have 4t to the 3/2 in the denominator for both of them, so we can combine it. So let's combine it. What are we going to have? We're going to have this thing minus 8 in the numerator, Yeah, minus 8 in the numerator, and then that's it. Want to be clear about this 3. This 3 actually belongs to this guy, and this 4 actually belongs to this guy. So in other words, I just want to make it clear that we're not distributing the 3 here like I had before. So I think this is good. So this would have a clear numerator and denominator that we can set to equal 0 at each turn, and then we can find the critical values. All right, so let's go ahead and put this in. Again, we can put in our first attempt at the derivative without simplifying, or we can put in this simplified version and when we get to compare. Let's make a fraction out of this, and then in the numerator we'll have 3, and that's t raised to the 1/2, and then we have a minus 8, and then in the denominator we have a 4, and then this is a t raised to the 3/2. Oops, I got an extra parentheses here. I think that's fine. Okay, let's check it. And again, their version might be different. Here they use the radical signs and the 4th root sign, but it's equivalent because we got a check mark. It's the same thing. All right. The critical numbers occur when h of t is equal to 0 and also when h of t is undefined. So that is when we get to sort out when the numerator is equal to 0 and the denominator is equal to 0. So h of t is equal to 0 when the numerator is equal to 0, which occurs at the following values. So what we need to do is we need to solve for this equation by setting this numerator equal to 0. So let's take that numerator and set it equal to 0 and see what we can find. Let's bring the 8 over to the other side. That becomes a positive 8. So take that away, put a positive 8 over here. Let's divide by 3. And then let's take the square root. This is a square root, so to undo the square root we have to actually square this. So if we take this t to the 1/2 and we square it, we're going to get just t, and that means we also have to take this guy and square it. And that would be 64 over 9. And that's the only time it's going to happen. So let's type in 64 over 9 and see if they take it. All right, so that's our one place where the numerator is equal to 0. And we also want to check when the denominator is equal to 0, but the denominator is just one term. And so we set that equal to 0, and that's going to equal to 0 when t itself is equal to 0. So the two critical values we have put together are 0 and 64 over 9. Now a good thing to do after you do these problems is to graph it to make sure we understand what's happening. It looks like when the numerator is equal to 0 at this point, 64 over 9, what we have there is we have a 0 slope. When the denominator is equal to 0, that means our slope is vertical. Our tangent line is vertical. So if we take a look at the Desmos graph, we see here that at 0 we have a vertical slope. As we approach 0, it's actually defined at 0, 0, 0, and we have basically a vertical slope. So that's when the derivative is undefined. And over here if we put 64 over 9 in your calculator, we should get something like 7.1-ish, and that's going to be our slope of 0, a tangent line of 0. Now, if we want, if you're curious about the graphs, we can see if this thing actually crosses the x-axis. With this particular viewpoint, it doesn't look like it. But if we solve for this thing, set this equal to 0, we see that it actually will end up crossing the x-axis. And for this, I'll just zoom out, and we see that it crosses the x-axis here at 64. So if we set this equal to 0 and do some factoring or do whatever we need to do, we'll see that it's equal to 0. Okay, so that wasn't part of the question, but I think that's an interesting aspect of the graph. Okay, that's your critical points.